Welcome to the lesson on the division algorithm for polynomials. At the end of this lesson, you will be able to divide one polynomial by another polynomial. You will also be able to state and verify the division algorithm for polynomials. Let's perform a simple division of 36 by 5. Notice that the quotient is 7 and remainder is 1. We can recall Euclid's division algorithm here. That is, the dividend is equal to the divisor into the quotient plus the remainder. In this case, 36 is equal to 5 into 7 plus 1. Suppose we have polynomials as the dividend and divisor. To perform the division, first we arrange the terms of dividend and divisor in decreasing order of their degrees. Thus, the dividend becomes x cubed minus 6x squared plus 12x minus 8. Let's perform the division. First, we'll divide the first term of the dividend, x cubed, by the first term of the divisor, x squared. We get x. This is the first term of the quotient. We multiply the divisor with the first term of the quotient and subtract this product from the dividend. That is, we multiply x squared minus 3x plus 2 with x and subtract the product x cubed minus 3x squared plus 2x from the dividend. The remainder is minus 3x squared plus 10x minus 8. Now, this remainder is our new dividend. The divisor is the same. To get the second term of the quotient, divide the first term, minus 3x squared of the new dividend, by the first term, x squared of the divisor. So we get minus 3 as the second term of the quotient. Multiplying the divisor with the second term of the quotient and subtracting the product minus 3x squared plus 9x minus 6 from the dividend gives x minus 2 as the remainder. Now, x minus 2 is our new dividend and the divisor is x squared minus 3x plus 2. Can you perform further division? Let's see. In order to get the third term of the quotient, we divide the first term, x of the new dividend, by the first term of the divisor, x squared. On division, we get 1 divided by x, which is not a polynomial. Thus, this cannot be the third term of the quotient. Therefore, further division is not possible. Here the degree of the remainder, x minus 2, is 1, but the degree of the divisor is 2. This implies that division is not possible if the degree of the remainder is less than the degree of the divisor. In general, the division algorithm for polynomials states that if f of x and g of x are the polynomials such that the degree of f of x is greater than or equal to the degree of g of x, where g of x is not equal to 0, then there exists unique polynomials q of x and r of x such that f of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or the degree of r of x is less than the degree of g of x. This is known as the division algorithm for polynomials. Let's now verify the division algorithm for a polynomial division just performed. Here you have divided x cubed minus 6x squared plus 12x minus 8 by x squared minus 3x plus 2. On performing the division, the quotient is x minus 3 and the remainder is x minus 2. Now, we'll substitute the values of the divisor, the quotient and the remainder in the algorithm. Let's simplify this. We get x cubed minus 6x squared plus 12x minus 8. This is the dividend that we have taken. Hence, we have verified that the division algorithm holds true for polynomial divisions. You have reached the end of this section. Let's recap the division algorithm for polynomials, which states that if f of x and g of x are the polynomials such that the degree of f of x is greater than or equal to the degree of g of x, where g of x is not equal to 0, then there exists unique polynomials q of x and r of x such that f of x is equal to g of x into q of x plus r of x. where r of x is equal to 0 or the degree of r of x is less than the degree of g of x. Hope you enjoyed this learning experience.